Welcome to our tutorial over forces and free body diagrams. If you were wondering what FBD meant, that is what it means. So, let me advance my slide here. So, remember from our Friday lesson, Newton's law of motion. There are three. The first one is inertia. An object in motion will stay in motion, and an object at rest will stay at rest until something is acted upon it, like an outside force. Our second law of Newton gives us our F net, our force net, equals mass times acceleration. It gives us our lovely little formula, and it says, or it means that the acceleration of an object is inversely proportional to the mass and directly proportional to the magnitude of the net force. And it is in the same direction as the net force. And then, of course, our third Newton law tells us that forces come in pairs. So for every action force, there is what we call an equal and opposite reaction force. Forces cause changes in motion. They are usually some sort of push or a pull. For example, weight, friction, tension, a spring force, and an applied force. Usually there are many forces acting on an object at once. In order to determine the net force, we need to draw what we call free body diagrams, aka FBDs. So, what is the net force? Remember, it is the resultant or overall force on an object. That is the net force. So, what are the steps we need to take in order to draw our FBDs? Our free body diagrams are diagrams that are used to show the relative magnitude. Now remember that means size and number, and then the direction of all forces acting upon an object in a given situation. So instead of numbers, we have these little check marks. This would annoy me if I were you. So I would go ahead and write 1, 2, 3, 4. So there's four things that we need to keep in mind. Number one, in a free body diagram, the object is represented by a box or dot. Sometimes you may see a dot in the middle of a box. 2. The size of the arrow is going to reflect the magnitude of the force. That's the same way that we drew vectors, remember? 3. The direction of the arrow shows the direction that the force is acting. Remember that. 4. Each force arrow in the diagram is labeled to indicate the exact type of force. So our next slide is going to give us our label choices. The label for our forces are going to be F subscript T or capital T. This is going to be force due to tension. For example, a rope or a cord. Our force with a subscript capital N is what we call our normal force. This is always perpendicular to a surface. Okay. Our F subscript, or our force subscript little f, is the force of friction. This opposes motion. Our F little g, or Fw, is our gravitational force or weight that is down. Our Fa is always our applied force. This could be a push or a pull coming from some other object or person applying the force, hence the applied word. And then we have our Fs, and that is our force exerted by a spring. This is fun stuff. So if we look right here, we have net force. The net force is the vector sum of the forces acting on an object. Okay? All right, so I'll have to reveal the answer. So our net force here is because we have 5 newtons and 5 newtons of applied forces. The total net force is going to be 10 newtons. Here we have a force that's going in the direction of our 5 newtons to the left and 5 newtons to the right. That's going to be a 0 net force, 0 newtons. Here we have a force coming from the right, 5 newtons, and a force coming from the left of 10 newtons. Our net force is 5 newtons. So it's pretty simple. Now remember, always go back to basics to keep these things straight in your head. Okay, so now let's do some free body diagram drawing. So here we have a free body diagram. Well, no, not yet. We're going to make a free body diagram. Now there is a applied force, okay? An applied force, and that applied force is actually coming from where it says push. So let me get my, well, I think I have a way to write on here. Where's my pointer options? Uh, let's see here. Let's draw. Oh, here we go. Okay, that's lovely. Let's erase that. Okay. So I'm going to try to do these in different colors. So let's see. Now, here I've got to remember all my different types of labeling forces. Okay, and my applied force is actually coming from the right, so I have to draw my arrow this way. And that is my FA. That's an A. I also have my normal force. And my normal force is actually pushing from the bottom upwards. Actually, we're supposed to draw right in the middle. Oh, that's purple. I thought it was a different color. This is my FN, normal force. I also have a gravitational force. It's pushing down from the top down. That's why we're drawing it right here. And then I have a friction force. I guess we'll have to do black. Now the friction force is this table right here. So it would be coming this way. And that is my F, little f. And that's how I draw my free body diagram for this little box. Okay. Now, we need to make a free body diagram for the following picture. So here we have a spring, and that is actually where force is coming from, and that spring is going to be pushing upwards from the box, in the center of the box this way. And that is my spring force. Notice the spring. Okay, right there. Fun stuff. Then I have, I'm sorry. No, I did it right. Okay. Um, my G looks like an S. Then I always have a force that's always pushing down, and that is my gravitational force. Okay, so that's how we make a free body diagram for a spring. So now we had to make a free body diagram for this double picture. Pretty interesting. So we have a rope or a cord in between these two objects. So we're going to have to do a double diagram here. Okay, so let me get my colors. Let's go ahead and draw our FG on both of them, starting from the center. This is my FG. This is a cool pen. It's a rainbow. Okay, now remember that force is coming from this direction. but we draw it that way because that's where it's coming from. It can be confusing on how to do this stuff. Okay. Now, let's talk about my applied force. I have an applied force coming actually from this box right here. So this is my applied force. That's an A. It's kind of hard to do it with this fat marker. Okay. Then I have a force of friction. I'm going to do right here, F, little f, okay? And I have it right here too, so I'm going to go kind of halfway. So this is also force of friction, but not only is it force of friction, but it's also force of tension, big T, or F subscript big T. So we have F of T here, and we also have it here. There's F of T here too, because there's friction between both, tension between both of these. And then we have one more to label, and that is the floor pushing back up, which is our normal force. Because the floor is pushing back up, or this table, whatever it is pushing back on these two objects. Okay. So, moving forward. Now, according to Newton's first law, if the net force is zero, then we say the forces are balanced or in equilibrium. This means that the motion is not changing. It may be at rest, may be moving at a constant velocity. So according to this second law, if there is a net force, the object will accelerate, meaning it will start moving, it will speed up, change direction, or slow down. Now, this is all information that we talked about on our lesson on Friday. So I'm going to stop the video here, and in class we will do example 4. Thank you for watching.